Things I want to address today. Exact answers versus, I should just say VS, approximate answers. Because you're going to get different kinds of instructions. Some will ask for exact answers. Some will ask for approximate answers. Okay? So, exact means right on. It means exactly that answer, right? What does approximate mean?
Close.
Around there, close to. It's a little bit of, if you think of the world in black and white, that's the gray area, right? It's not concrete. It's, we're rounding off things. Approximate answers are always rounded decimals. I say always, and that's not entirely true because there is this thing called estimation, which might not be rounded decimals. But for our purpose, answers are always rounded decimals. Exact answers could be nice numbers. And that's the Franken way of saying whole numbers. Like 5. Why are we like... That is... Okay, there we go. I think we're better. So, a rounded decimal or an approximate answer of 1/3 would be if I have this 0.33333333, right? And I'm sure you've seen lines like that. Yes? 0.33, depending on how far you round. Now, you don't need to put those lines, because if it asks for an approximate answer, you're kind of saying approximate twice by putting those lines. Sometimes. Now, before I get into more of that, I want to talk briefly about rounding decimals, because there are some people that still have issues with rounding decimals. And I tried to look for a worksheet on rounding decimals, and unfortunately they were all like 3rd grade and like help the bunny through the pasture. Like I wasn't going to go there, okay? So I'm just going to talk about it for a minute. So I'm going to give an example of a decimal, 0.34827. And now it could have more digits past there, but for our purposes, that's enough. We know that the first digit past the decimal is the 10th place. Right? What's this digit right here? This is the ones. And over here we have the tens. This side we have all the ths at the end, the THSs. Okay? So that's the tenths. What's this one? Hundredths.
But it does make sense.
These are powers of 10. 10 to the first is 10. 10 to the second is 100. 10 to the third is the thousandths. That's my next one.
3rd grade's backwards. You know what?
After the thousandths is the what? 10 thousandths. And you know what the last one is that I have there?
Maybe it could be 20,000 million. It could also be 100,000 million. 100,000.
Now, you do not need to know all of those things. We focus for the most part on the first 3. Tenths, hundredths, thousandths. And your instructions that you get generally will always say round to the tenths, round to the hundredths, or round to the thousandths. Okay? So, if this was my decimal and you were asked to round to the nearest tenths, or the nearest tenth, you look at the tenths place, yes, but that's not what, that number right there in the tenths place does not determine what gets rounded. What determines what gets rounded? The number that's in the next column over, the hundredths column. So that's a 4 over there. What does that tell me about the tenths column? it's going to stay as a 3. If that 4 was a 6, what would I have?
4.
That would change to a 4. So since that's not 5 or higher, I'm going to stay at 0.3. So in other words, if I ask you to round off to the nearest tenth, I'm expecting 1 digit past the decimal, but you have to look at the second digit past the decimal in order to determine what that number is going to be. Does that make sense? If I asked you to round to the nearest hundredth, again, looking at this decimal, the 3 I don't even look at anymore. It's going to be there. But here's the hundredths digit. The next digit over tells me if that changes or if it stays the same. The next digit over is an 8, which means it's going to change it. So this is going to become a 5 because the digit next to it is 5 or higher. That makes it change. Think of it like 48. That's closer to 50 than it is to 40, right? Same idea. So this becomes a 3, 5. The 3 stays the same. The 5's got to change. All right, you round it for me to the nearest thousandth. So that same decimal, round it to the nearest thousandth. So you look at this thousandth, and then you look at what's next to it. Does that 2 mean I have to round the 8 up or down? Down. Right? Meaning it stays the same. Like, if you look at this like the number 82, that's going to round to 80, not 90. Right? So it's going to stay as an 8, so I have 0.348 would be that rounded. Only if I said to round to the nearest hundred. Okay? If I'm rounding to the nearest thousandth, you never look at more than one number to change. So I can't change this to a 5 unless that's my final digit. If this has to be my final digit, that 4, nothing happens to it. It stays as a 4. Okay? Otherwise, I'm changing things all over the place and things get messy. These are the things that you need to be able to round to. The tenths, the hundredths, the thousandths. Okay? Now, if I get, again, I have nice numbers and I have rounded decimals. If I get a number like radical 2 as my exact answer, yes, that is an exact answer because it is a simplified radical. Yes? What if I asked you to find that approximately rounded to the nearest hundredths? How do I round that to the nearest hundredth? Well, I can go to my calculator. I'm going to go to my calculator and type in the square root of 2. Now, your calculator should have a square root button. Mine happens to be right there. I feel like I'm zoomed in too far. I'm going to zoom out a little bit. Is that okay? I can't. How come I can't zoom out? There we go. How about that? So the square root of 2 is this decimal right here. So if I need to round to the nearest hundredth, that means the second digit past the decimal is going to be my last digit, right? Yes? Does the 4 to the right of it mean that 1 stays a 1, or does it mean it becomes a 2? Stays a 1. So what am I going to say this is approximately? 1.41. Okay? So there's a little bit about exact versus approximate. The other thing I want to tell you, or want to talk to you about, is simplifying radicals. Okay? Because we're getting a lot of radical answers as we're using our distributive property, right? So if I get something like this as my answer, that's not a simplified answer. Just like if I got an answer like this, that's not a simplified answer. What is it, or if it was simplified, what would it be? We always go to here, don't we? We never leave it like that. We always simplify. That's what we're going to be doing here. So I'm going to explain this a couple different ways, and I'm hoping it's going to help.
Wait, that is...
Now, as I'm talking about this, the key to simplifying these has to do with things called perfect squares. What are perfect squares? 1 squared is equal to 1. That means 1 is a perfect square. 2 squared is equal to 4. That means 4 is a perfect square. 3 squared is 9. That means 9 is a perfect square. 4 squared is 16, which means 16 is a perfect square. What would the next perfect square be? 25. After that, 36, 49. Those are all called perfect squares. Yes. We are going to focus here. And the reason why we're going to focus there is because we don't need to think about the higher ones as we're reducing here. So I want to keep 4 and 9 in my head here. You ready? Can 40 be divided by 4 or 9?
Yes.
Yes. Which one can it be divided by? So I could say that radical 40 is the same thing as radical 4 times what? 10. Now, whatever that number is, I want it to be a 4 or a 9. If it can't be divided by 4 or 9, then don't worry about reducing because that's all it can do. Okay? Now, radical 4 times 10 can be written like this. Radical 4 times radical 10. Why is that important? Well, what is the square root of 4? Isn't this just 2 times radical 10? That's the simplified form of radical 40. Can I show you how I know that both of those are the same thing? Because watch. I'm going to show it on here so you can see it better. Hopefully it will last because my battery is dying here. But if I typed in the square root of 40, I get that decimal. If I type in 2 square root of 10, I get the exact same decimal. Do you see that? Those are the exact same thing. One is not simplified. One is simplified. Do you understand? Now, if I asked for exact versus approximate, both of those are exact because neither of them are a rounded off decimal. And approximate is rounded off decimals. Now, I would technically like to look at 10 and see can 10 be divided by 4 and 9? Can't be divided by either. That's how I know I can't take 10 any further. Okay, so let's try that on another one. We're just going to practice a few of these. Can 12 be divided by 4 or 9? 4 and 9 are the golden numbers. Those are the ones we're focusing on. It can be divided by 4. 12 divided by 4?
3.
Is 3, right? So I can call this square root of 4 times 3, which turns into the square root of 4 times the square root of 3, and the square root of 4 we know is 2, so I have 2 radical 3. So why am I looking for 4 and 9? Because 4 gets me that number that doesn't have to be in a radical. 9 would do the same thing because what's the square root of 9? 3. That would give me another thing that doesn't have to be in a radical. Okay? What if I gave you this guy? Square root of 24. Can that be divided by 4 or 9?
4.
It can be divided by 4 again. So I would call that square root of 4 times what? All right. So that's the square root of 4 times the square root of 6. What is the square root of 4? 2. Radical 6. And you're done as soon as this number that's left in the radical can't be divided by 4 or 9 anymore. Now, sometimes you may get one. Actually, I don't want to go there yet. What about this one?
9.
It can divide by 4, can't it?
Wait, so it only works if it's something you can divide by 4?
No.
4 or 9?
Or 9.
That would be what? 4 times 12, right? So, square root of 4 times the square root of 12, and we know the square root of 4 is 2. Am I done?
No.
Why not?
It's 12.
Because 12 can be divided by 4 also. I can keep going. So, I'm just going to keep this 2 hanging on for the ride there. This is 4 times 3. So I have 2, and then radical 4, and then radical 3. And all of this stuff is connected by multiplication. So what's going to happen here? 2 times 2 times radical 3.
4.
So what does that become?
4, 3.
4 radical 3. Could I have gotten to that answer easier?
Yes, you could.
Yes. Remember how I said, is it divisible by 4 and 9? 4 and 9, 4 and 9. Those are the easiest ones to keep in mind. However, 48 happens to be divisible by 16, which is another perfect square, right? 48 divided by 16 is 3. So I could have done this, and the square root of 16 is 4, to get to my answer. If I could have divided by 16, I could have gotten there. I ended up getting that square root of 4 because I took out the 2 at 2 separate times. Okay? So if you can think of a bigger number, let me rephrase that. If you can think of a bigger perfect square that it's divisible by, it'll get you to the answer faster. If you can't think of a bigger one, stick with that 4 and 9 and you'll get there if you just stick with it. Okay? Raise your hand if you prefer using the tree method. Anybody prefer using the tree method? Okay? Let me show you the tree method for 48. And I have no preference of whether you understand or whether you use the tree method or whether you use this. Doesn't matter to me as long as you're using it correctly. So the tree method says you take two numbers that multiply to get 48. Well, what are two numbers that multiply to get 48? 2 and 24. Are those the only two numbers that multiply to get 48? No, 16 and 3 multiply, 4 and 12 multiply. There's lots of different options, aren't there? It doesn't matter which ones you choose. Because as you keep going, two numbers that multiply to get 24, 2 and 6, 2 and 3. As you keep going, no matter what you chose there, you will still end up with 4 2s and a 3 at the bottom of your tree. Okay? Even if you started with even like 6 and 8, you'll still end up with 4 2s and a 3. So remember, this is all technically under a radical, right? So if I have 2 2s under a radical, remember this is all multiplication, that's really a 4 under a radical. Yeah? A 4 under a radical is a 2 not under a radical. So in other words, if I have a pair of 2s, that means I have a 2 outside, because that's really saying that's the square root of 4. If I have another pair of 2s, that means I take out another 2. And if I have a loner 3, he's got to stay at home because he doesn't have a pair. So where do I go? I get 4 radical 3. It's just another way of getting there. Okay? Again, doesn't matter to me whatsoever which way you choose to go on that. Okay? All right, one more I want to show you. Actually, I want you to try this one. Whichever way you are most comfortable doing it, can you simplify the square root of 72? Okay, so 72. I know that is radical 4 times 18. Raise your hand if you did 4 times 18. Okay, I'm assuming the rest of you either did the tree or you did 9 times 8.
Yes.
Yes? I'm going to show you both of them. Okay? 4 times 18 gives me rad 4 times rad 18. And rad 4 we know is 2. And then 18 I can say is 9 and 2. And I still have this 2 out front. So I have 2, rad 9, and rad 2. And all of this is multiplication. So 2 times 3 times rad 2 gives me 6 rad 2. Okay, let me finish this one. If you went this way, this gives me rad 9 times rad 8. Rad 9 is 3. But rad 8 can go further, can't it? Because rad 8 is divisible by 4. because it's 4 times 2. So that gives me rad 4 times rad 2. So 3 times rad 4 we know is 2 times rad 2. There's my 6 rad 2. Did anyone use the tree method? Okay, let me show you the tree method. 72. Again, you could put 4 times 18, you could put 9 times 8, you could put 2 times 36. It doesn't matter as long as the two numbers do indeed multiply to get 72. I'm going to do 9 times 8 if that's okay. 3 and 3. And then this would be 2 and 4, 2 and 2. Whichever way you went, you should have 2 3s and 3 2s circled at the bottom of your tree. Whichever way you went. What am I looking for? Because remember, this is under a radical. Pairs, right? Pair of 2s means I'm taking the square root of 4, which means I have 2 outside. Pair of 3s means I have a 3 outside. And then that last 2 that doesn't have a buddy, that one has to stay inside. 2 times 3 gives me 6 radical 2. Okay? Now, quick question. What if I asked you, not for the exact answer, which is what we just found, what if I asked you to approximate, you ready? To the nearest tenth. What do? I go to my calculator, I type in 6 radical 2, or 6 times radical 2, either way, and I look at that decimal. 8.48. I'm looking for the nearest tenth, which means I look at the tenth, but then I look to the right of the tenth. That 8 means the tenth is going to become a 5. So approximated to the nearest tenth would be 8.5. Again, that would be an approximate answer. The 6 radical 2 would be an exact answer. Okay? So I want you to keep those things in mind as you go through tonight's homework. Now let me explain tonight's homework to you really quick. All right? On the front side, you have 4 segments that have been graphed. You need to find the midpoint and the distance for those segments. Okay? It does not specify exact or approximate. If it doesn't specify, give me the exact answer. Okay? Don't approximate unless you absolutely have to. That makes things less accurate. Then we have ones back here where I give you the points, not the picture. These are the ones where we gave you the end point and the midpoint, and you had to find the other end point, which we did on yesterday's notes. And then these last ones are kind of interesting, because there's a picture over here with a lot of stuff going on, and it asks to determine whether the segments have the same length. So I'm going to find segment AB, and I'm going to find segment CD. How do I know how long segment AB is? By using the distance formula. The distance formula tells you how long the segment is. How long is the segment? Well, it's the same as the distance from this point to that point. So I use the distance formula to find out what AB is. I find the distance formula to find what CD is, and whichever one's bigger is the longer segment. If they're the same, then what? They're the same length. Okay? Again, exact answers I want to see there. However, you may also need to get an approximate answer, because sometimes it's hard to, in my brain, think, oh, 2 radical 3, that's equal to blah, blah, blah as a decimal, and be able to compare it to something. So you may need to give both forms of the answer there as far as approximate and exact. Okay? All right. We'll pass that out, and happy studying.